The solid outermost shell of the Earth is called the lithosphere. This includes the crust and the upper solid part of the mantle. On average, it is 50 kilometers thick beneath the oceans and 70 to 100 kilometers thick under the continents. The continental lithosphere and the oceanic lithosphere also differ in composition. The continental crust floats on the asthenosphere, the viscous upper part of the mantle that lies beneath the lithosphere. The movement of the lithosphere, which can be observed in a great number of places, is the reason behind earthquakes and volcanic activity. These movements do not take place randomly, but along longitudinal belts. Volcanic activity and earthquakes mostly occur at the edge of continents, oceanic island arcs, oceanic trenches, and mid-ocean ridges. These motion processes mark the boundaries of tectonic plates. The lithosphere is not uniform. It is broken up into tectonic plates of different sizes. Today, we know of 7 major tectonic plates and a number of other smaller ones which all move in relation to each other. The 7 major tectonic plates are the African plate, the Eurasian plate, the North American plate, the South American plate, the Pacific plate, the Indo-Australian plate, and the Antarctic plate. The theory that describes the motion of the lithosphere is called plate tectonics. There are 3 types of tectonic movement: convergence, divergence, and subduction. Mid-ocean ridges represent an example of divergent plate boundaries. As magma, that is molten rock, rises from the asthenosphere and penetrates the oceanic lithosphere, it reaches the surface, where it cools down and solidifies, forming new lithosphere at the edge of the crack. That is how mid-ocean ridges are formed. As it expands, the mass of molten rock pulls the seafloor apart, causing the tectonic plates on either side of the ridge to move away from each other. Thus, the ocean basin grows wider, a process called seafloor spreading. That is how, for example, the Atlantic Ocean has been formed over 10 million years. However, since the surface of the Earth cannot increase continuously, the surface of oceans cannot increase continuously either. The opposite boundary of the oceanic plates approaches another plate. When the 2 tectonic plates collide, one plate moves beneath another. This is called subduction. The subducting plate moves into the asthenosphere, where it is melted and incorporated into the mantle. At subduction zones, volcanoes, fold mountains, and deep-sea trenches occur. Examples of mountain ranges formed as a result of subduction are the Andes and the Himalayas. On rare occasion, 2 adjacent plates slip along a fault, resulting in an earthquake. This is the case with the San Andreas Fault in California. Oceanic lithosphere is formed continuously at mid-ocean ridges and disappears at oceanic ridges. Thus, the size of continental plates and the location of dry land are continuously changing.